Welcome. Graphing quadratic functions, also known as parabolas. Any function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers and a cannot equal 0, is called a quadratic function. The graph of a quadratic function is a parabola. So let's look at the basic parabola. F of x equals x squared. What we want to do first is find the highest or lowest point by considering the domain and range. This point is called the vertex. Now the domain, there's no restrictions on what x can be. So the domain is all real numbers. This means we could choose any values for x. Now the range is different. The range is from 0, including 0, to infinity. And that's because the smallest value we could obtain for y is 0. And this is when x equals 0. So when x equals 0, the graph will have a point at the lowest point of our graph. So when we plug in numbers into the equation, f of x equals x squared, the smallest number we could get is 0. We're always going to get positive values. Any number you pick for x, when you square it, becomes a positive. So there's no way you could get a negative number. However, the smallest number you could get is 0, and that's when x is 0. So this is going to determine the points that we're going to choose. We're going to pick the value that gives us the lowest or highest point. In this case, it's 0. And then we pick 2 points to the left and 2 points to the right. So 0 is going to go in the middle of our table. And then what's to the left of 2? Right, -1 and -2. And then what's to the right of 0? 1 and 2. So those are the numbers that we're going to plug into this function to get the y values. You could use a calculator or do it by hand. For instance, if you plug in -2, you're going to get 4. Plug in -1, you're going to get 1. Plug in 0, 0 squared gives you 0. +1, 1 squared is 1, and 2 squared is 4. So those are our points. That's 5 points. That's good enough. Plot those points and then we'll sketch it. It has a U shape. So make sure your parabola kind of looks like that. It's called like a U shape. Okay, sometimes we talk about translations, vertical translations and horizontal translations. As far as this video goes, we're mostly going to talk about just picking points. However, you should also know about translations. If it's in this form, f of x equals x squared plus k, that number vertically translates the graph up k units if k is positive, or down k units if k is negative. So here's our next example. F of x equals x squared minus 3. So it's going to have the same shape as the last example. However, because there's a -3, it's going to shift it 3 units. Which way? Up or down? Is k positive or is k negative? It's a -3, so it's going to be the same graph, just lowered by 3 units. Now, as far as the domain and range, again, I like to pick points. The smallest value we could get is 0 again, and that's when x is 0. Sorry, that's not true. The smallest value we could get is -3, and that's when x is 0. Okay, so we're going to pick the same numbers. We're going to choose x equals 0, and then 2 to the left, and 2 to the right. Okay, so this time our domain again is all real numbers, but our range is -3 to infinity. And we get -3 for y when we choose x equals 0. Okay, fill in the table and then plot your points. And there you can see it's the same graph as the last example, just lowered by 3 units. So that's what that number does after the x squared. If it's +3, it moves it up 3 units. If it's -3, it moves it down 3 units. The next kind of translation is called a horizontal translation, and it moves the graph left or right. Okay, so in general, a graph of a function of the form f of x equals x minus h squared, where h is a real number, horizontally translates the graph of the function f of x equals x squared to the left h units if h is negative, or to the right h units if h is positive. Now notice that there is a minus sign. Because that minus sign, it's kind of like we have to think the opposite of what you would see. All right, here's our example. F of x equals x minus 3 squared. So in this case, is h positive or is h negative? Look at the form above, f of x equals x minus h. There's already a minus in that form. So when we look at this example, there's already a minus, so our h is positive 3. Therefore, h is positive. So it moves the graph to the right 3 units. So it's going to be the same graph as f of x equals x squared, but moved to the right 3 units. Now, as far as our domain and range, our domain is still everything, right? All real numbers. Our range, well, the smallest we could get is 0. So it's from 0 to infinity. And it's 0 when x is equal to 3. So what I like to tell students is whenever you see parentheses, pick the value that'll make it 0 inside the parentheses. So that would be a positive 3. Okay. So the smallest value we could obtain for y, this is when x equals 3. When x equals 3, the graph will have a point at the lowest point of our graph. So we're going to choose x equals 3. Might want to pause it. There's a few notes here. But again, we're picking the number that makes it 0 inside the parentheses. And then from there, 2 to the left and 2 to the right. So 1 and 2, 4 and 5. Pause the video. Work those values out so you can get the y values, and then we'll come back, plot it, and have the graph. So there's our graph. Again, it's the same graph as f of x equals x squared, but moved to the right 3 units. This function, f of x equals x plus 3 squared minus 2, has 2 translations. It has a horizontal translation and a vertical translation. Inside the parentheses, what is the number that would make it 0? Right, negative 3. So I'm asking what number plus 3 equals 0, and that would be negative 3. So it's moved to the left 3 units. And then the minus 2, that moves it up or down. So inside the parentheses, think in terms of opposite. It says x plus 3, so think of the opposite of plus 3, which would be negative 3. And outside, you take the same number, so minus 2, that means it's going to be moved down 2 units. Okay, so start with the x value. That's going to be negative 3. And then we're going to choose 2 numbers to the left and 2 numbers to the right. So think about negative 3 on the number line on x. What's to the left of negative 3? Negative 4, negative 5. What's to the right of negative 3? Negative 2 and negative 1. All right, work those out. Okay, here's our results. Plot the points. And there's our sketch. So same parabola, just move to the left 3 units and down 2 units. Okay, this one doesn't have parentheses, so it's not moved left or right. There is a plus 2 on the outside, so that means it's moved up 2 units. However, there's a negative in front of the x squared. So what do you think that negative does to the graph? Yeah, what it does is it flips it upside down. So this U shape will be upside down. All right, so we're going to find the x value of the vertex. Since there's no parentheses, it'll be 0. So if there's parentheses, opposite. No parentheses, always choose 0. And then this is going to give us what's called a maximum of the parabola. Because the parabola is upside down, it's called a maximum. So make your table, put 0 in the middle, and then 2 to the left and 2 to the right. Okay, work that out, plug it in. Make sure when you plug in the numbers, especially the negatives, to put the number in parentheses if you're going to use your calculator. Okay, so these are our results. Order of operations says you got to square the number first, then it makes it negative, and then you could add 2. So for instance, if you plug in negative 2, if you plug in negative 2, you have to square the negative 2, so put it in parentheses, square it. That gives you a positive 4. And then there's a negative in front, so now it makes it a negative 4. And negative 4 plus 2 is negative 2. Okay, plot your points. And then sketch it. And there's our parabola that's upside down. So that point at the very top is called the vertex. And in this case, it's called a maximum because it's the highest point on the graph. So a parabola either has a maximum or a minimum. All right, here's some notes. This is the standard form of a quadratic function. F of x equals a times x minus h squared plus k. The vertex is the point hk. Notice that again the h follows a minus sign, so that's why I like to say the opposite inside the parentheses, but plus k, the same number. Every parabola is symmetric with respect to a line that contains the vertex. The equation for the parabola's line of symmetry is x equals h. So whatever the x value is, there's a vertical line that means that both sides of the parabola is exactly the same. So if you look at your drawings of your parabolas, both sides are the same on that line x equals h, where h is the h value of our vertex. Okay, Not a big deal. I just want you to get some of this, some of these definitions. Okay, if a is greater than 0, the parabola opens upward. So if a is positive, it goes up. And if a is less than 0, if a is negative, it opens down. If the absolute value of a is greater than 1, then the parabola is narrower than the basic parabola. So if a is a 2 or a 3, that means your parabola is going to be narrow compared to our basic parabola, which is f of x equals x squared. If the absolute value of a is less than 1, then it's wider than the basic parabola. So if it's 3/4 or -1/2, what that will do is widen the parabola. Okay, if we do have it in this form, f of x equals ax squared plus bx plus c, the value a is still the value that determines if the parabola will open upward or downward or is wider or narrower than the basic parabola. So I just wanted you to know that those two a's are still the same. Now the b and c, that's different for the function, right? The top one has an h and k, and this one has a b and c. So those are not the same, but the a is still the same a. Okay, we're just using some of the information from the previous slide. Given the function f of x equals 2 times x minus 3 squared minus 7, find the following. Vertex, line of symmetry, opens up or down, or wider or narrower than the basic parabola. Okay, so first thing is vertex. Vertex is h comma k. So remember what I said about parentheses, opposite of the number inside the parentheses and the same outside. So what is our vertex? Good. Positive 3, it's always the x value first, positive 3, and then the same number on the outside, -7. So our vertex is positive 3, -7. How about line of symmetry? Well, the line of symmetry is just the x value, x equals h. So our line of symmetry is x equals 3. Okay, opens up or down? Well, does this one open up or down? We look at a. A is 2. That's a positive number, so what does that mean? It opens up. And is it wider or narrower? Well, if it's bigger than 1, it's narrow. So this one will be narrow. Since a equals 2, it is narrower than the basic parabola. All right, next example, vertex. What is our vertex? So inside the parentheses, opposite, outside, same. So our vertex is -1, 4. Line of symmetry, x equals -1. Opens up or down, our a is negative, so it opens down. And wider or narrower, it's a fraction, it's less than 1. So when we say absolute value less than 1, that means it's between -1 and 1. So this one is wider. If you get kind of confused, I wouldn't worry too much. Remember, once you pick the points, you graph it, and you'll see what it looks like. All right, here's our next example. F of x equals 2x squared plus 1. Okay, this one, vertex. There are no parentheses. So if there's no parentheses, what's our x value, or what's our h value? 0. And the k value is 1, so our vertex is 0, 1. So there's no parentheses, our x is always going to be 0. Now we're going to make a table, and you're going to start with 0, and to the left, to the right. Okay, use your calculator or just plug it in by hand to get the y values. Now we could plot those points and get a decent graph. So you can see it is a little more narrow than the other graphs that we've done. Not a lot, but a little bit. All right, here's our next graph. This one's got a -3 in front of the parentheses. What does that mean? It means it's going to go down. Is it going to be wide or narrow? It's going to be narrow. Okay, so if it's between 1 and -1, except for 0, it's wide. And if it's outside that region, it's narrow. Again, don't worry too much. Main thing is pick your points and it'll look just fine. Vertex. What is our vertex? Right, we have parentheses this time, so we got to take the opposite. What number would make it 0 inside the parentheses? That would be 2. And then our k value is 5. So when you make your table, just make sure you have 2 in the middle, the number 2, and then choose 2 numbers to the left of 2 and 2 numbers to the right. So 0 and 1 and 3 and 4. Use your calculator to get those for you or plug them in by hand, up to you. All right, now sketch it. And there's your graph. Okay, our next example that we're going to do is we're going to talk about completing the square. Hopefully you've done completing the square. So we want to use completing the square to write it in standard form, f of x equals a times x minus h squared plus k. Here's our example, f of x equals x squared plus 6x minus 3. Now, hopefully you remember, we take half of the x term and then square it and then add it to both sides. That's the procedure, but we're going to do it a little bit different because we don't want to add to f of x. All right, so the first thing is we're going to factor the a from the first 2 terms. Last time what we did is we divided by a, but this time we're going to say factor the a. This one doesn't have an a. It doesn't have a number in front of the x squared. So we're going to leave c alone, but we're going to leave a space for that number to be added later. So just kind of move the -3 over. Previously what we did is we added 3 to both sides, but we don't want to say f of x plus 3. All right, so all we did now is I put parentheses around the x squared plus 6x, leave a space, and leave the -3 outside the parentheses. Now this is the part where we're making a perfect square trinomial. We take half of the x term, then square it. We're going to add that number inside the parentheses. Then we're going to add the opposite outside the parentheses. So again, what we did is we added that number to both sides. But we don't want to add a number to f of x. That would just be weird, right? All right, so what's half of 6? Half of 6 is 3. And then we square it, we get 9. So we're going to add 9 inside the parentheses, but then subtract 9 outside the parentheses. I wrote it over just to see. You don't have to write it over again. You can just add that 9 to that first row you have. Okay, now the parentheses, that's a perfect square trinomial. You could factor it, or if you know the pattern, it's going to be a binomial squared. It's going to be x plus 3 squared, and then you just add your two numbers on the outside, which is negative 12. And we're all done. Okay, so again, in those parentheses, notice that the 3 that we have, that's a number before you square it. So you don't have to really search very hard for that number. 3 times 3 is 9, and 3 plus 3 is 6. So that's why the 3 is the same number. All right, let's try this one now. A little bit more complicated this time. We have to factor out the 2 from the first two terms. So in the note it says factor the a from the first two terms. In that case, it's going to be a 2. And then we're going to leave the negative 5 alone, but you're going to leave a space for a number to be added later. All right, so here we go. Factor out a 2 for the first two terms, leave a space, and put the negative 5 outside the parentheses. So we're just kicking the negative 5 over to get it out of the way. Even if that negative 5 was a number that 2 divides evenly into, let's say it was a 6, you still don't want to factor the 2 out from that number because we want to make a perfect square trinomial. So we want our own number inside the parentheses. Okay, take half of the middle term and square it. Now this one does have a 2 outside the parentheses. So in this case, we take half of our number, half of negative 4, which is negative 2, and then we square it, we get 4. So 4 is the number we're going to add inside the parentheses, but it's not really a 4. Because of the 2 outside the parentheses, the value being added is actually an 8. Therefore, negative 8 will be added to the constant. So again, you see that we put a 4 inside the parentheses, but that's not really a 4, it's really an 8. Because if you distribute back, you'll get 2x squared minus 8x plus 8. Therefore, we have to put a minus 8. All right, so you multiply those two numbers. So if there's a number in front of the parentheses, you multiply those numbers, and then you put the opposite outside the parentheses. So since that's a positive 8, when you multiply 2 times 4, you put a negative 8 outside the parentheses. Okay, now we can rewrite it as a binomial squared. So that's 2 times x minus 2 squared minus 13. All right, here's our next example. Very similar to the last one. This one is a negative 5 that's in front. So just keep that in mind if you decide to pause the video and work it out. You do the same steps. Just remember that it's a negative 5 in front of the parentheses, so you're going to have to multiply negative 5 times the number you add, and then put the opposite outside the parentheses. Okay, so first, factor out a negative 5 from the first two terms only. Leave a space. Kick the negative 18 outside the parentheses. Now we're going to take half of 4, which is 2, and then square it, we get 4. So 4 is the number you're going to add inside the parentheses. But is that really a 4? No, it's not a 4. It's a negative 20. Negative 5 times 4 is negative 20, so we're going to have to put a plus 20 the opposite. So negative 5 times 4 is negative 20. We need to put the opposite outside the parentheses. That's why it's a positive 20. And now we could write the perfect square trinomial as a binomial squared and then combine the two constants on the right. So negative 5 times x plus 2 squared plus 2. Okay, here's our next one. This one will have fractions. I know everybody loves fractions, and fractions happen. Follow the same steps. There's no number to be factored out. There's no a to factor out. So just kick the negative 3 outside. Take half of 5, which is 5 over 2, and then square it, 25 over 4. So it's going to be a plus 25 over 4 inside, a minus 25 over 4 outside. Now write the trinomial as a binomial squared and add the two constants. You could use your calculator to add those two numbers. Remember that inside the parentheses, it's always the number before you square it. So it's going to be x plus 5 halves squared. And you combine those two numbers on the right, and that should give you negative 37 over 4. All right, last one here. This one's a graph. And what we're going to do first is we're going to write it in standard form first. So we're going to factor out a negative 2 from the first two terms only. Kick the negative 17 to the right outside of the parentheses. Okay, so negative 2 times x squared minus 6x plus a space. The minus 17 is outside the parentheses. Take half of negative 6. What's half of negative 6? Negative 3, and then square it, 9. So we're going to add 9. But that's not really a 9, right? Negative 2 times 9 is negative 18. Therefore, we have to put a plus 18 outside the parentheses. And then rewrite it as a binomial squared. So that's negative 2 times x minus 3 squared plus 1. Okay, now we're not done. If that was, I don't know why I boxed it. Sorry about that. We're not done. We're just ready to graph it. What number are we going to choose? We're going to choose the number that makes it 0 inside the parentheses. So that would be 3. That's our vertex, so x is equal to 3, and then the k value is 1. So our vertex is 3, 1. So make sure you put 3 in the middle. We already know the y value is going to be 1, but you can also have your calculator find it for you. Now choose two numbers to the left and two numbers to the right. All right, use your calculator or plug them in by hand. Here are the values you should get. This parabola does go downward, right? Because it's got a negative in front. So when we're graphing, if our parabola doesn't go down, that's a red flag. Anyways, we'll plot our points. Yeah, that looks pretty good. All right, that's it for this video. I'll see you here for the next video. Have a good day.